Welcome to Everything Distributed. So the first topic we want to talk about is what is distributed system? Before I answer this question, let's think about what is computer? Why do we need computers? If you think about your daily life, your interaction with computer, you use it to process data, to store data, to communicate. But sometimes you find that, okay, it's not as powerful as you wish. So what do? You want to scale up, you want a more powerful machine. But for many tests, they are limited. Either it's too expensive, or either like there's another machines that's powerful enough for your task. So that's the beginning of distributed system. You can actually have many more machines to jointly to satisfy your need. And that's why we are interested in distributed systems. And there are tons of examples that we are using in our daily life, like from the simplest one, like client-server model, then the internet you are using today, and wireless network, your mobile phone, and then any kind of peer-to-peer systems. Or if you are using cloud, you use Amazon, use like Google Cloud, use Microsoft Azure. Yeah, this kind of cloud computing is a very typical example for distributed system. A more futuristic one, you have distributed robots, large-scale sensor network, or like cryptocurrency. These are all typical example for distributed systems. And so now I say, okay, give me some definition. That is still very vague. Okay, so there are lots of very great textbook about distributed system, and one of them is by Andrew. It defined as a distributed system is a collection of independent computers that appear to the user of the system as a single computer. And this is a very typical definition. However, it's still a little bit limited because that in many distributed systems, we don't actually want it to be like a single computer, even though it's a very powerful abstraction. And then the next one's by Michael, which is a kind of a slightly more complicated one. Is okay, we have several computers, they are doing something together. And then the three primary characteristics is that you need to have multiple of them, and then you need to have way to communicate between them, and then you need to share something between them. Okay, so now these three components are very important. Now let's look at another one by Indy. By the way, he's a great instructor, and I highly encourage you to check his lecture slide. So in his distributed system course, he said, no, okay, actually distributed system is really hard to define. So let's have a working definitions. And then as you get to know more and more about like formalism or like applications, we can add more and more definitions. So first, distributed system, the computation entity is not arbitrary one. It needs to be autonomous, you need to be programmable, and then in terms of environment, it needs to be asynchronous, like you need to deal with some kind of failure, and then for communication, it's not any type of communication. Instead, the medium is unreliable. And then starting from here, it's a very solid model for like our internet. And starting from there, we can study all kind of different kind of distributed systems. And then I would say that for engineer, or if you are software engineer, that's a very accurate view for like the daily kind of a test that you will deal with for distributed systems. But like for me, it's I'm more interested in both like kind of theoretical work in distributed computing and also for the distributed system. So my definition is a little bit general. First, I just said that we have a collection of entities, and then it doesn't really matter how I define the entities. But like Michael's definition, I also want them to have some form of communication. So if you think about this, our biological ecosystem actually is a distributed system. The market we are having, our society, and then a cell interaction, these are all distributed systems. So actually what I want to say is that distributed system or distributed computing in general is not just a man-made system. It's not just an engineering system. Our nature, our kind of organic interaction is all part of the distributed system. And then, of course, that we still want this kind of collection of entity jointly. They want to solve something, even not explicitly, but like there are some kind of properties or characteristics that we want to analyze. And then for me, that's a perfect definition for distributed system. So like three things, we have a collection of entities, and then you need to have some kind of communication, and then jointly they want to solve something. And then that's the thing that we are going to deal with in everything distributed. Okay, now hopefully you have a vague idea of what distributed system or what distributed computing is. Then the next big question is that why should I care? And before I go into detail, I want to share like one book I like really much. I like it a lot. If you are a computer scientist, if you work in software, I highly encourage you to read this. It's 9 Algorithms That Change the Future by John McCormick in 2012. So like he looked at tons of algorithms that we are using today. He said that this 9 algorithm actually change our world, and then we are actually use them like in our daily life. And then if you look into them, all of them, all but one, except for the pattern recognition, are somewhat related to distributed system. And then if nowadays for this kind of machine learning, pattern recognition, or in general AI thing, it also run on top of distributed system. So here is a kind of my feeling right now. It's very famous in Silicon Valley that software is eating the world. And then what's behind the softwares? Algorithms, they are behind the software. And then as we saw in the previous slide, what's behind the algorithm? Where do you run your algorithms? It's on top of distributed system. So that's what inspired me the name Everything Distributed, because I think it's safe to say that almost everything will be distributed or will be run on distributed system. And then that's why this distributed computing is so fascinating. It's a good area to study on. And then don't take my word for it. Now look at like what market think, what like some consulting firm, market analysis kind of company thing. And then like Gartner, they do lots of trend prediction. And then here's what they predict for 2020. And then I think that all of them, I think it's like somewhat related to distributed computing. But here, like the edge computing, the distributed cloud, autonomous things, and practical blockchains, those are distributed systems. And in fact, we are going to see some of them, at least some of fundamental ideas behind all those things in everything distributed. And then if you look at our life, I know that many of you want to work in a big tech company, tech industry. They are using tons of distributed system. If you check that this a good set of slide by this person, sorry, I don't know how to pronounce it. It document that back in 2015, what kind of technology stack, what kind of system they are using. And I would say that almost all of them are distributed systems. So you need to be familiar with them to really work in like top companies in industry, tech industry. And then if you look at your personal life, you are using Instagram, Facebook, WeChat, your info, your bank, your life is on the cloud, and then it's inside distributed system. And then if you look at our interaction, our society can be modeled as a distributed system. So that's like closely related. Okay. Then you say, okay, I don't really care about this. I just want to know that what kind of research can I do? What are some exciting research topic? And then I can tell you that distributed computing is related to lots of things. If you take a more traditional sense, and then you can check like Facebook and Microsoft and UIUC, how do they divide the system area? Then you have distributed system. Distributed computing is related to system more on the side OS side, or on the networking more on the communication side, or you someone more work on the security, or even on the parallel computing, for example, like GPU, and then like CUDA, that kind of thing. And then it's also like have a close synergy with like lots of emerging research area. We have network science, natural computing, mobile computing, all type of different kind of simulation, cloud computing. And then I'm more kind of even more advanced one. You have large scale machine learning thing, optimization, biology, psychology, robotics, smart grid, tons and tons. And then everything is related to distributed computing. So now I think it's a golden age to work on, or at least to know something about distributed computing. Okay, then you say, hopefully now you stay with me. You say, well, that's a cool thing. How do I start? And then I think as a computer engineer or computer scientist, the first thing you want to know is that we build a mental model. We want to have some kind of abstraction. So what's an abstraction for distributed system? And then first, or maybe one step back, what is abstraction? And abstraction is a super important for computer science. It's a kind of you can think about it's a fundamental concept or the API of the US software. And then it's closely related to how you model your system, how you want to provide different kind of functionality, how you build your system. And then if you like to work in both like theory and design and practice, you need to start with abstraction. And then here is a more traditional one. So if we work on a single computer, we have the hardware, firmware, and then up until our operating system and application. And if you are interested in computer networks, then OSI layer model is a very common one. You have like kind of physical communication, and here we have IP layer, and then we have the transportation protocol, UDP, TCP, all those kind of things. And in terms of a distributed system, what do we have? Unfortunately, there's like distributed system are just like too complicated. So there's no universal kind of abstraction or layering. And here I start with some simpler one is called message passing, which we will go into more details later. So like for message passing on the bottom layer, you can think about that as a unique case. Some way of doing communication, meaning that for any pair of nodes or any pair of entities, one can send a message to the other. That's unique case. And then on top of that, we study lots of different kind of distributed primitive, which provide like different properties. And on top of primitive, we can start building our programs, software, and then within this layer, programs and software, there might be different layers inside. And then there are lots of different kind of primitives. We will go over most of them. We have a gossip, how to do different kind of a communication called multicast broadcast with different property, different ordering property, and some kind of storage, and then maybe failure detector. How do I detect someone is in the membership in the system? How do I do take a snapshot? How to achieve agreement? How to synchronize the clock? That's all and more on the fundamental side. Okay. Then once we have a set of primitive, then now we can start building a different kind of system, more practical. All of these are very practical system. We have Cassandra, a storage system, Bitcoin, a cryptocurrency, BitTorrent, that share for you to share file, data, Hadoop, that kind of big data computing, cloud computing, and all different type of fascinating systems that we are going to talk about. Okay, so the takeaway is that First, what is distributed computing and what are some common definitions? And then second is that why should we care about distributed computing? How is it related to other research field? And then finally, a very vague model for the abstraction or the layering for the distributed system and some of the example primitives that we are going to talk about. Okay, thank you. That's all for today.